welcome to the 10th episode in the mathsonlinetuition.com videos going through the C1 book. We're carrying on with chapter 4, specifically section 4.5 where we left off. We're just doing something a bit different in this episode because I think it's of value to start at the end, okay, before we go back to the beginning of our subsection, because it will be of benefit to appreciate the rules that we're going to encounter in a few moments. So the summary of key points always found in the end of the chapters is going to summarize for us what we need to understand before we continue on the subsection above, particularly these transformations, okay. Now it says fx plus a is a translation of minus a in the x direction. Fx plus a is a translation of plus a in the y direction. Fax is a stretch of 1 over a in the x direction, multiplying x by 1 over a. And afx is a stretch of a in the y direction, multiply y coordinates by a. What does this mean if you're scratching your head? This means the following, okay? If you have a graph as such, fx equals this, then the graph is shifted to the left by a coordinate points. So for example, if you have x to the power of 2, okay, and we all know what that looks like. If you don't, here it is here. Then the graph is shifted to the left by a coordinate point. So imagine if this plus a, and it's all within the brackets, was to be 3. So then this 0 would eventually become minus 3 because it's been shifted to the left. Okay? If fx equals this, right, then x minus a, once again we say if it's minus a, say a is 3, then this would be shifted to the right, okay, will be shifted to the right by a coordinate points. Now if fx equals x squared plus a, then this would be shifted upwards, okay. So again, if a here was to symbolize 3, you would have on this side starting at 3 instead of 0, okay. And likewise, if a is minus, alright, as is here, then it will be shifted down, alright, and it will be minus 3 if a was 3 in our example. Excuse me. And the same follows here. If for example you have x3 plus 1, this will be shifted up by 1. X cubed minus 1, again it will be shifted down by 1. And if it was, for example, open brackets x plus 2 close brackets 3, remember the plus 2, but this time because it's in the brackets it will be shifted to the left by 2. So this 0 would start over here, say if this was 2. Alright, pretty simple, pretty straightforward, okay. And likewise for this asymptote, same thing here, 1 over x, right? Now if we had for example 1 over x plus 1, okay, over here, then again this will be shifted up, right? So the rules are all there for you. Now let's get to the question, section 4.5, so that we can show you some diagrams, okay. So here we go. 4.5. Now you can write this out, what we have here. It's completely up to you. If you don't, that's fine. I'm going to remove it now. So we can see that we have, let's draw it more practically, fx squared very multicultural with all these wonderful colors, and you can see that this would be touching 0. So just to my inaccuracy of drawing, should be touching the origin, going through the origin. Now if we had fx equals x squared plus 2, okay, then we would say that this would be our graph 2, okay. If for example we had fx equals x squared minus 2, we would have minus 2. If we had, in another example, fx equals open brackets x minus 2 squared, right? Then we would have the negative would give us a shift to the right. So we would have, for example, starting at 2. And then finally, if we had fx equals x plus 2 squared shifted to the left, so we would have something like this, minus 2. Okay, so here's a nifty little diagram for you to follow, and hopefully that helps you to appreciate the quadratics. So if you look further on, you can see that they also do a similar thing, fx plus 2. Here you can see that fx minus 2, they shifted it to the right. Very simple, very straightforward. Here's an example that you can carry out. Here's an example of a cubed. So they've just obviously said x is equal to 0, y is equal to 0. So it comes, this is the intersection of the axes. And then we've said take a number on the x side, 5 for example, and because it's cubed, it keeps growing, goes to plus infinity. Likewise on the other side where x becomes negative, because it's a cubed, y will become negative, so that it will keep going to minus infinity. And then as you can see, the rule once again, x plus 1, it's in the bracket. So what does that mean? That means that it gets shifted to the left. Okay, and then here's the other example whereby you have your graph drawn out. Okay, and then they've said further on, now imagine that y equals g x plus 1. Here's the plus 1. So what do? Shift it to the left. Okay, and you can see they've done that because here you have 1, but we originally had 2, and here we had 0. Now we have minus 1. Okay, easy for you to go through on your own. Here's an asymptote. Again, hx equals 1 over x. So y now equals hx plus 1. You can write this out as, so if hx equals 1 over x and y equals hx plus 1, you can equivalently write this as y equals 1 over x plus 1. Okay, same thing. We have the plus 1, so what does that mean? That it's going to be shifted up. So you can see how they have this 1 dotted here just to show you. Okay, scroll down and here you have some other exercises that you can go through in your own time. And then we come to the set of final rules, okay, which refers to expanding and reducing certain axes. Okay, so if we have, draw this out. So it says here, you can transform the curve of function fx by simple stretches of these forms. Fax is a horizontal stretch of a scale factor 1 over a, so you multiply the x coordinates by 1 over a and leave the y coordinates unchanged. Afx is a vertical stretch of a scalar factor a, so you can multiply the y coordinates by a and leave the x coordinates unchanged. Let's take the first point and explain it a little bit more. So if you have Fax, okay, the horizontal stretch of a scale factor 1 over a. So multiply by x coordinate by 1 over a, and leave y unchanged. Okay, so they've given you example here. So given that fx equal 9 minus x squared, and then you have f2x. Okay, so what they've done here is they have 9 minus x squared. So this is the factorized form, and then they've obviously said, right, where does it cross at the axis? So when y is equal to 0 on the x-axis, that means you have 3 according to their example and minus 3. Okay, so now x is equal to 0. This means that y crosses at 9. Okay, 9. So the curve is drawn as such. Comes back down. Should be going through there. Okay, now let's apply the rule, the 2x rule, the 2x. So remember what we said, if there's an a, what's our a here? Well, in this particular case it's 2, so we have a equals 2, and it says multiply by x coordinate by 1 over a and leave y unchanged. So y stays as 9, leave it as that. Use a different color. 3 multiplied by 1 over 2 is what? Well, half. 1 over 2 is a half, so what's the half of that? It's going to be minus 1.5, likewise here 1.5, and then y is unchanged, so it comes back down like that. Here you can see the answer. Very simple, very easy, quick to do. Okay, just to give you another way of approaching this, they have created a shortcut here whereby they say y equals fax, where a is equal to 2. So it's a horizontal stretch with a scale factor 1 over half. They've multiplied, or instead of putting this is fx, right? This is equal to fx, but they've put in their example here 2x, so you can put the 2 here and a 2 here, and if it was, for example, y equals f3x, then you could have 3 minus 3x, 3 plus 3x. Okay, completely and totally up to you how you want to approach it. And then obviously you would say, well, in this particular case x has to be equal to minus 1 and x has to be equal to 1. Okay, and then you would again draw 1, minus 1, the y-axis stays the same, and then it comes back down. Alright, very easy. Once again, nothing difficult about it. So here is example 18. We won't go through it, but as you can see, this is the original yx. There's a 3 on the outside. Remember what we said, that when it's phrased as a coefficient, then the x stays the same, however the y is changed. So this will be steeper, so it's a vertical stretch. Okay, and you can see that it all crosses the same on the x-axis, but it gets steeper as the number increases. Likewise in here, if you have a third, then a is 1/3, so 1 over a is going to be 3, because, well, 1 over 3 is 3. And likewise for this next example here, 1 over x same thing. They have the values, okay, and they have accordingly followed the rules. Some more examples, and these are just exercises for you to do now without any examples, so it's throwing you more into the deep end. Please do work through them, try to figure them out. Okay, so 4.7. You need to be able to perform simple transformations on a given sketch of a function. So this is very simple. Once again, they're basically wording these questions a little bit more to get you thinking, but it's exactly the same operations as you've done before. The following diagram shows a sketch of the curve fx which passes through the origin. The point A, 1, 4 and B, 3, 1 also lie on the curve. Point to mention here, this is not a coefficient. You do not multiply A. You do not try to find out what A is in order to multiply the coordinates by them. It's not a scalar, right? It's just referring to the point A, okay? In this particular manner it is written out. So we have fx plus 1, fx minus 1, fx minus 4, of course being mindful of the brackets and where they are. This is your given curve, and so you have to now transform it depending on the different types of transformations. So again, this has been if you can see, fx1 is moved to the left because of the plus, move to the right because of the negative. When I say move to the move to the right, move to the left, again, you know, look, you've got 2 here, it's moved to the left because there's a plus 1 here where it was originally 3, so you've taken away that 1, okay. And y, again, the y stays the same because the y is only affected when the number is outside of the brackets, as you can see here, okay. So it's moved down because it's negative. And then we have the exercises here that you can do. So look, you've got this diagram again, and then it's asked you plus 1. So what would happen here? You would move to the left. So you would have, for example, this is 0, 2. So now it would be minus 1, 2. This would be 0, 0. This would be 3, 4. Okay, what about for B now? So the number is outside, the transformation command is outside of the brackets. So that means the whole thing is going to be shifted down. So what would happen by 4? So this would be 0. Remember that the horizontal, the x coordinates are unaffected, only the y in this particular case. So you have minus 0, minus 2, 1, minus 4, 4, 0, 6, minus 4, and so on and so forth, so on, so forth, so on and so forth. Okay, very simple, very easy. And to be honest with you, look, all these examples are pretty much the same. There's nothing different or unusual happening here. Okay, nothing. Look, you've got here the x has been negativized, so you need to think about what that means. What does that mean? It's simple. All the x coordinates now have been negativized, so you need to make everything else negative, corresponding to the x coordinates, that is. Okay, mixed exercises, and then you can go through that. It's just an amalgamation of all the exercises with regards to the subsections that we've done before. And then here we go. We have the summary of key points, which we've already gone through. Alright, so that's the end of chapter 4. In our next episode, we'll go over chapter 5. Thank you very much for listening, and we'll see you next time. Bye bye.